Let's begin. Today's May 22nd, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and the 6 verification cards. Let's go to turingmachine.info for the details. So again, our puzzle today uses the following 6 criteria cards. Criteria card 2, 5, 9, 16, 19, 21, and uses the purple verification cards. Above, you'll find the unique identifying code for this puzzle for today, and you could always use it to go back into turingmachine.info and get the details again. All right, let's go solve. All right, so in our grid above, we've got our 6 criteria cards, beginning with criteria card A, criteria card B, criteria card C on the top row, and in the bottom row we've got criteria card D, criteria card E, and finally criteria card F. So if we look at criteria card A, this card will look at the first digit, the triangle digit, and compare it to the number 3. Should the triangle value be less than 3, equal to 3, or greater than 3? Criteria card B looks at the same digit, right, the triangle, the first digit, and will let us know whether that value should be an even or an odd. Criteria card C will look at the whole code, all 3 digits, and let us know how many 3s there are in the solution. Should there be no 3s, 1 3, 2, possibly all of them could be 3. Criteria card D does a similar thing, except it then only looks whether the digits are even or odd, and will let us know if there are more evens than odds, or vice versa, less evens than odds. Criteria card E will look at the first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will look at the whole code and let us know if there is a pair of digits, repeating digits, as in the example 131. Alternatively, if there is no pair, then the alternatives are that they all have unique digits, are all unique, as in the example 134, or potentially it could be a single digit repeated 3 times, as in the example 222. Remember, we're looking for this one particular unique 3-digit code that meets all of these criteria. And we're going to begin with our proposal of 314. So the first thing I'm going to do is I'm going to test criteria card B to figure out if that first digit is even or odd. Okay, so the Turing machine responds that it does not accept my value for triangle. Notice that I have triangle be 3, so it's telling me no, the triangle value should not be odd. In fact, it should be even. So that's what I'm going to put down in my notes in section B. That triangle is an even digit. And so what I'm going to do is I'm going to cancel all the odds for triangle. So I'm going to cross out 1, 3, and 5. Now, of course, we don't know if it could be a 2 or a 4. We just know that triangle should be an even digit. Let's see. Even though criteria card A looks a little bit tempting, right now it's just a 50-50. It could either be 2, which would be less than 3, or 4 greater than 3. I think I'll hold off on looking at this criteria card until a second round. I'd rather kind of get a feel for the whole solution. And that said, I think what I'm going to do is I'm going to look at criteria card F and see if there's a pair. Okay, so the Turing machine approves of my proposal. Notice that in my proposal I have 314. Those are all unique digits. So that means that there is no pair of digits in my solution. So that's what I'm going to put down here in my notes. So no pair. No pair of digits. Now at this point, we don't quite know whether they're all unique or a single digit repeated 3 times. The likelihood that it's the latter, where it's all the same, is rare, but we still have to keep it in mind. That said, I don't think I can eliminate any numbers for this particular criteria card, so I'll move on and see what criteria card D tells me about the number of even and odd digits. So let's test criteria card D. Okay, that it also approves of. So again, if you look at the initial proposal of 314, I've got 2 odds to 1 even. It approves of that. So the question is, are there 2 odds or 3 odds? Well, we already know that triangle is an even digit, so that means that we have 2 odds, and it happens to be square and circle. So for criteria card D, I'm going to say that even should be less than odd, and then say obviously that square and circle are odd, and furthermore, now that we know that we have 2 odds and 1 even, we can conclusively say, yeah, it can't be the same digit repeated, right? I've got at least 1 even and 2 odds. So that means that down here, I'll add the note that all digits are unique. Okay. So where does that leave us? And again, I don't think we can eliminate any possibilities, even with those. Oh, actually, I take that back. Yeah, of course we can. We can cross out the evens for both square and circle. So crossing out all the evens. So yeah, so our solution is going to be even, odd, odd. And of course, there's no repetition, so we know we're going to have some kind of combination of 1, 3, 5, but no duplicates there. Okay, so anything else? Yeah, I think that kind of gives us a general idea of what the solution is going to be. So as now I'm going to go into thinking about how to construct my second proposal for this next round. So we know that again, if you take a look at the whole criteria cards, there's no mention of purple. So typically the way I think about that is that the purple digit is going to be forced into something. And so obviously the combination of these criteria cards will force that. So somehow knowing what the even for triangle is and the odd for square, somehow that's going to force purple to be something specific. And so, as I mentioned in the previous round, criteria A at this point looks like it's a 50-50 because it's either going to be 2 or 4. The number of 3s, well, we know that there can't be 3 3s, right? And also there can't be 2 3s because there's no pair. So either there is a 3 or there isn't. Now what I like about this card, and I'm just doing it like a thought experiment, is that if there are no 3s, then we know the 2 odds are got to be 1 and 5. So that could be a potential path towards the solution. We also know that the sum, we haven't tested the sum, and the one thing we can say about the sum is that obviously it can't equal exactly 6, because an even plus an odd will always be an odd. So let's see, can we, I'm really gravitating to the fact that I think if there, could we somehow say there are no 3s and it'd be a 1 and a 5 in some order? If we picked 1 for square, we would know for sure that the sum would be less than 6. but I don't know if we'd be able to distinguish that. But maybe, well, let's see, if we think about it, if it's less than 6, one would work for both, so I don't think we would be able to distinguish that. Same thing with, say, greater than 6, 5 would always work. So maybe there is a 3 and the sum is either less than or greater than, but then we would know what to pick for purple, 1 or 5. So I don't think square could be a 3, because again, if it's 3, then one test could tell us the sum is less than 6 or greater than 6, and so we'd pick that even, but then we wouldn't be able to figure out what purple is. Remember, we're trying to force purple into something. What else could it be? If it's not 3, yeah, that would be less than 6. All these would be greater than 6. Yeah, man, I'm really torn. Trying to think of some alternative possibilities. So if I'm right and 3 can't be or square can't be 3, then what if purple were 3? Would that matter? Obviously, if there's 1, can we then force, I guess, square to be one or the other? I don't see that happening. Yeah, I'm thinking that there are no 3s, but then how do I choose the sum? Because it seems like there are too many possibilities. Well, okay. I'm just gonna give it a shot, and I'm gonna say, let's do, oh, okay, never mind. So yeah, I guess I really didn't think about, if I know what triangle is, it's gonna force me to pick 2 or 4. And so I think then what I'm gonna do is I'm gonna do 2, 5, 3. I'm gonna force it to be a 7, but using the 2. That forces a 5, and then I guess technically then either the 3 is there or not. So okay, so yeah, I'm gonna do that. 2, 2, 5, 3. 2, 5, 3, and it's there or not. Yeah, we'll have to test it, I think, but let's go with that. Okay, so first I do want to test, let's see, which one is better, A or E? I'm going to test A. Okay, so it did not approve of my 2, so that means that triangle has to be greater than 4. So I'm going to say here, I apologize, triangle has to be greater than 3, but because it's an even, it will be a 4. So triangle has to be greater than 3, so that means it's a 4. So that means I'm going to eliminate the 2, and so I'm left with 4. So now what could the sum be? So in this case it could be, there are 2 possibilities for it being greater than 6, and then only that one possibility where it's less than. Well, let's go test criteria card E and see what we get. Okay, so it does approve of the sum being greater than 6. Notice that in my proposal, 2 plus 5 gives us 7. That is greater than 6. So that in itself, the only thing we can do is cross out the 1, because both 4 and 3 and 4 and 5 give us, okay, well, let me just add to my notes for E that the sum has to be greater than 6. So we've got triangle plus square needs to be greater than 6. And so again, the only thing I can cross out is a 1. Okay. And so let's see. At this point, I'm thinking that there are going to be no 3s to force it to be a 5 and then a 1. So, well, let's see. Do I have to test it? Let's do this. Let's list out all the potential solutions and see if we can deduce something. So again, it could be 4, 3, 1, 4, 3, 5, or 4, 5, 1, or 4, 5, 3. Okay, so we know the first one's always 4, yes. And so we have 2 possibilities, 3 or 5 in the middle. So we'll do 4, 3, 1 and 4, 3, 5. Remember, no duplicates, or 4, 5, 1 and 4, 5, 3. Okay, so both of these have a sum that's greater, or they all have a sum that's greater. And the first digit is greater, so that's good, and it's even. The last 2 are odd, the sum, yeah, and they're all unique. Okay, so again, we know that there can be only 1 3 or no 3s. So can we... So this is the only one that, has no 3. So maybe that could be a possibility. All the other ones, can we somehow distinguish? I think maybe, let me give it a little bit more thought here. If it is, it says, oh, there is a 3, then I guess the question is, how do you distinguish all the ones that do have a 3? Because all of the other criteria are met. So that's what I would call ambiguous solutions. That's even. Yep, they all have more odds than evens. They all have a sum that's greater. Yeah, I think I can eliminate all the ones that have a 3, because there's no way to distinguish should it go in the first, or sorry, for square or triangle. Okay, so let's see. Yeah, because that's the only thing that differentiates everything else. So yeah, I'm going to say that that is the answer, 4, 5, 1. There is no 3. All right, so 4, 5, 1 is what I'm saying is my official answer. We've already kind of confirmed based on all that. We did not test criteria card C, so this may be one of those where we may beat the Turing machine by maybe a couple of questions. All right, so let's go to turingmachine.info and confirm our answer, 4, 5, 1. Okay, fantastic. Yeah, we did it. So it was a great exercise to, think about it, list the solutions, and we were able to do it without testing criteria card C. It's still important, but there's no way to distinguish all the crossed out potential solutions. So let's see how I'm pretty sure we beat the Turing machine. Let's just see by how much. So in our first round, we did B, D, F. So let's go do that, B, D, F. I believe B was wrong, but D and F were correct. And then for the second round, we did A and E. and that was wrong, and E was correct. And so let's see, how do we do? Yeah, as I thought, we were going to beat it by 2 questions. So the Turing Machine went into a third round, and we were able to, do it just in 5. So that's fantastic puzzle. It definitely kind of challenged us to think outside the box. Don't shy away from listing potential solutions and seeing if there's nothing that really kind of ties them all together. So obviously all the 3s were hard to distinguish. Well, again, this was a great puzzle. I hope it was helpful and enjoyable. It was for me. So if you like this video, please give it a thumbs up. If you don't want to miss out on the following video, make sure to subscribe. And until next time, have a good one.